This is a presentation of the Bruker Esprit software version 2. To start the software, we work from a desktop icon. You simply double-click. It brings in the login environment. Each analyst can have their own login, and you can set level of expertise. So you can have a basic, advanced, and supervisor mode. Upon starting the software, you have the workspace list here, which are your various operations and controls. And on top, you have your configuration bar, which allows you to set defaults for both the software and the hardware for the analyst. Our most basic controls are spectral collection, object mode, which allows us to collect images and spectrum, annotate the image so that we can collect spectrum at various locations about it. Very nice tool to check for homogeneity, document differences within the sample, or just general quantitative analysis. Digital line scans for recording chemical compositional changes along an area. Digital mapping, in particular hypermapping, which allows us to collect all the X-rays in the field of view and then be able to extract spectrum, maps, line profiles from any region about the sample. Image processing. This allows us to take any image, do arithmetic operations, transform functions, kernel processing. Also segmentation, so we can extract area fractions, panoramic for tiling images, and then direct measurements. Feature analysis for particle size and chemical classification of data. And then electron backscatter diffraction, commonly known as EBSD, to look at surface crystallinity of single crystals about the sample. Jobs is for automation. Anything you do routinely can be automated. Scripts is for advanced automation. This allows you to use a full programming language within the environment. And then system allows you your configuration. In this, setting up your hardware and your hardware defaults. The appearance of the system, how you want your KLM markers to look. What defaults you want for the display axis, whether you want things like a grid, how you want your default quantitative analysis. Spectrometer. This is used for calibrating your X-ray spectrometer. You simply select the modes of operation, the element of interest, and the system does the rest. So regardless of who calibrates, we all come back with the same result. Image magnification and stage calibration. WDX control if so equipped. Communications with the microscope. This is typically set up for you by the serviceman when he installs the system, and then communications with the stage of the microscope. Again, this is typically set up at time of installation, and this will vary from microscope to microscope. So now we select what operation we wish to do for our analysis. On the top portion of the display in the Esprit software, these are your configuration bars. This controls your software and your hardware features. Sample allows you to set a prefix for the day. All files will start with this. You can use automatic numbering. You can always edit the name at any point in time. It also allows you to input functions that you may be wanting, such as operator name, analyst's name, or the date of acquisition. If you coat your samples and you're utilizing the coding correction, this allows you to preset on the system what you've coded with and what correction to use when you do your analysis. Standards is for using and setting up your libraries of quantitative standards. In Quant, if you elect to use a standard, you can use pure element, multi-element, oxide standards. You can have multiples of the same element within the same library. You can have separate standards for intensity and for deconvolution. And you can create as many libraries of standards as you wish. Microscope is the communication with your microscope. At the time of acquisition, we get the latest information of the microscope, in particular magnification, the accelerating voltage, and the current working distance that you're at. We also will pick up the current stage information as appropriate. Scan is for the digital beam control. We can collect up to 2 video signals simultaneously from your microscope if your microscope outputs 2 video signals. You can collect images from 100 on up to 4096 pixel resolution. Again, we'll match the aspect ratio of your microscope. So if your microscope's 1:1, 4:3, 3:4, whatever, you get to set the x-axis. We set the y-axis proportional based on the aspect ratio which you're working at. You have separate controls for image acquisition, digital X-ray maps, and also digital line scans. Within those controls, you have individual controls for pixel or dwell time, pixel averaging or dwell time, line scans. It gives you, based on your pixel size, what the scan time will be for that mode. And you have also 8 external inputs for other accessories. So you can add up to 8 additional accessories such as WDX, cathodoluminescence, and we can read those communications into here. Also, if you have beam drift correction, that is activated here, and also you can set your defaults for how you wish that acquisition to go. This controls our spectrometer configuration. So what throughput mode we want to work with. We used to call this shaping time in the past. Also, what resolution we were going to work with. In this system, we'll collect 4,000 channel spectrum at all time. That divided into the energy range gives you your EV per channel. So you can have 2.5, 5, 10, or 20 EV per channel. Typically for an SEM, we recommend 20K EV range. For people using the X-Trace, our micro XRF system, or general TEM usage, the 40K EV range is ideal. And then the 80 for doing high order analysis with your TEM. Mode turns the spectrometer on or off. From room temperature, we can cool down your spectrometer in 30 seconds. We have built-in diagnostics to check and verify that everything is working. OK means everything's fine. If there were a problem, the system would automatically point that out. It also currently shows me my spectrometer is running at minus 30 degrees Celsius. Typically, our spectrometers run between minus 20 and 40 degrees spectrometer, depending on the application. There's a built-in report writer. This is totally user customizable, so you can set templates up with your corporate logo, how many objects you wish to place in the field, customize it for a particular application. Anything you put in the report is active, so you can update your KLM markers, your colors, your quantitative analysis while you're in the report. Also, when you're finished with the report, you can concatenate it with any previous reports or output the results directly to Word or save it as a PDF. Projects is a scratch folder that allows you to save your spectrum, your images, X-ray map images as well, all into a single common file, and then allows you to recall it. It's a nice convenience for if you're working on a job that has many different pieces of data and you want to keep it together. The system also allows you to save data anywhere you wish. So if you're using a disk farm, you have discrete folders on your hard drive, you can save data to any of those at any time. Other important thing to note, notice as we select each object, we only go one level deep on all our menus. This makes the learning curve much quicker. Also, as you select your workspace operations, so whether you're doing spectrum, doing object mode, collecting an image and doing spectral analysis, or doing digital line scan, all your controls are located here, and they're very repetitive. So only the things that are unique for that analysis are up there, and any common controls remain the same. Also, any place you see, again, a down arrow key means that's the menu for that operation. And this will allow you to select how you want to collect your data, what options you have available to you, whether you want to do an automated analysis within the system, and where you want to save your data at the end of acquisition. Also, it allows you to turn on the automatic numbering at any point in time. So to do an analysis, it's simply select the operation you want to do and then start your acquisitions.